Today, let's talk about real number system. Definition of real number system. A binary operation on a set A is a function f mapping a times a into a. A times a is a Cartesian product. On the set R of real numbers, there are two binary operations, denoted by plus and dots. They are called addition and multiplication respectively. These operations satisfy the following algebraic properties. First one, a plus b equals b plus a for all ab in R. That's commutativity of addition. Bracket a plus b plus c equals a plus bracket b plus c for all abc in R. That's associativity of addition. There exists 0 in R such that a plus 0 is equal to a for all a in R. That's existence of a 0 element. For all a in R, there exists b in R such that a plus b is equal to 0. That's existence of negative elements. A times b equals b times a for all ab in R. That's commutativity of multiplication. Bracket a times b times c equals a times bracket b times c for all abc in R. That's associativity of multiplication. There exists 1 in R, distinct from 0, such that a times 1 is equal to a for all a in R. That's existence of a unique element. For each a in R different from 0, there exists b in R such that a times b is equal to 1. That's existence of reciprocals. A times bracket b plus c equals a times b plus a times c for all abc in R. That's distributivity of multiplication over addition. Theorem. Cancellation law for addition. If abc belong to R and a plus c equals b plus c, then a is equal to b. Cancellation law for multiplication. If abc belong to R and c is not 0 and a times c equals b times c, then a is equal to b. Both 0, 1 negative element and reciprocal are unique. A times 0 is 0 if a is a real number. Proof. Similar to proofs of theorems related to vector space, which is shown in one of my uploaded videos, having the title of Vector Space Over a Field. You can take a look at it. As both negative elements and reciprocal are unique, we denote the negative element and the reciprocal of x to be negative x and x inverse, respectively. Subtraction is defined by a minus b equals a plus negative b for ab in R. Division is divided for ab in R with b is not 0 by a divided by b equals a times b inverse. For convenience, we write ab for a times b. Order properties of R. There is a non-empty subset R plus of R, called the set of positive real numbers, that satisfies the following properties. 1. If AB is positive, then a plus b is positive. 2. If AB is positive, then a times b is positive. 3. If a is a real number, then exactly one of the following holds. A is positive, a is 0, negative a is positive. 3 is usually called the trichotomy property, since it divides R into 3 distinct types of elements. It states that the set bracket negative a such that a is positive of negative real numbers has no elements in common with the set R plus of positive real numbers. That is, a real number cannot be both positive and negative. Moreover, the set R is the union of 3 disjoint sets. Definition of inequalities. Let AB belong to R. If A minus B is positive, we write A is larger than B or B is smaller than A. If A minus B belongs to R plus union the set containing 0, we write A is greater than or equal to B or B is less than or equal to A. Let AB belong to R. By the trichotomy property, exactly one of the following holds. A minus B belong to R plus. A minus B is 0. Negative bracket A minus B belongs to R plus. A minus B is positive, implies A is greater than B. A minus B is equal to 0, implies A is equal to B. Negative bracket A minus B is positive, implies A is less than B. Therefore, exactly one of the following will hold. A is greater than B, A is equal to B, A is less than B. Theorem. If both A is less than or equal to B and B is less than or equal to A, then A is equal to B. Proof. As A is less than or equal to B, we have B minus A belongs to R plus union the set containing 0. Then B minus A is positive, or B minus A is 0. Then A is less than B, or A is equal to B. So A is greater than B is false. As B is less than or equal to A, we have A minus B belongs to R plus union the set containing 0. Then A minus B is positive, or B minus A is 0. Then A is greater than B, or A is equal to B. So A is less than B is false. Since both A is greater than B and A is less than B are false, we conclude that A is equal to B. For notational convenience, we will write A is less than B is less than C to mean that both A is less than B and B is less than C are true. The other double inequalities are defined in a similar manner. Rules of inequalities. Let ABC belong to R. If A is greater than B and B is greater than C, then A is greater than C. Proof. If A minus B is positive and B minus C is positive, then bracket A minus B plus bracket B minus C is positive by the order properties of R. Then A minus C is positive, so A is greater than C. If A is greater than B, then A plus C is greater than B plus C. Proof. If A minus B is positive, then bracket A plus C minus bracket B plus C equals A minus B is positive. Then A plus C is greater than B plus C. If A is greater than B and C is greater than 0, then CA is greater than CB. Proof. If A minus B is positive and C is positive, C times bracket A minus B is positive by the order properties of R. Then CA minus CB is positive. Then CA is greater than CB. If A is greater than B and C is less than 0, then CA is less than CB. Proof. As A is greater than B, we have A minus B is positive. As C is less than 0, we have negative C is positive. So that CB minus CA equals negative C times bracket A minus B, which is positive, by the order properties of R. So CA is less than CB. Theorem. If A is a real number and A is not 0, then A squared is greater than 0. Also, 1 is greater than 0. Proof. By the trichotomy property, if A is not 0, then either A is positive or negative A is positive. If A is positive, then by the order properties of R, we have A squared equals A times A, which is positive. Also, if negative A is positive, then A squared is equal to negative A times negative A, which is positive. We will conclude that if A is not 0, then A squared is greater than 0. Since 1 is a real number and 1 is not equal to 0, then 1 equals 1 squared is greater than 0. Theorem. If AB is greater than 0, then either bracket A is greater than 0 and B is greater than 0, or bracket A is less than 0 and B is less than 0. Proof. If AB is greater than 0, we have A does not equal to 0. Since if A is 0, then AB is 0. From the trichotomy property, either A is greater than 0 or A is less than 0. If A is greater than 0, then A inverse is greater than 0. Then B equals A inverse times AB is greater than 0 by the order properties of R. If A is less than 0, then A inverse is less than 0. Then B is equal to A inverse times AB, which is less than 0. Corollary. If AB is less than 0, then either bracket A is less than 0 and B is greater than 0, or bracket A is greater than 0 and B is less than 0. The proof is left as an exercise. This is the end of the video. If you find my video interesting, please consider subscribing to my channel, liking my video, and commenting down below. Thank you. See you in the next video.